Okay, I am back at it here with part 2 of the midterm exam review. Let's jump back into it. So I believe I stopped with question 37. So I will start here with question number 38. And I see right out the gate that we have our special right triangle, 30, 60, 90. And I got to make sure that I label my sides correctly. The side across from the 30 is the short side, so I'll label that S. The hypotenuse is my 2S. It's twice as long as the short leg. And then the long leg across from the 60 is my short side times the square root of 3. Okay, so they gave us a short side. That's always the easiest when they give us that. Thank you very much. So to go from short side to the long side, I'm simply going to double it. Go from S to 2S, I double it. So 2 times 3 root 3 is going to be 2 times 3. I just multiply the two numbers in front, and that gives me 6 root 3. Okay, I'm just doubling the short side. Now to go from the short side to the long side, it's the side times the square root of 3. But the short side is already 3 root 3. So I'm taking 3 root 3 times another, slap on another root 3. Root 3 times root 3 is just 3, and then 3 times 3 is equal to 9. And so we have found the remaining sides of the triangle. All right, number 39 here. Okay, I pulled this one off of the internet. This is an SAT type question. Okay, they love to ask these kinds of questions. What is this in terms of this, in terms of this? Okay, normally we're solving for size or whatever, but they're saying, what is the length of AB, this whole length here, in terms of A? Okay, well here, A is my altitude here. This is 45, that's 90 degrees, so here's our classic 45, 45, 90 right triangle. This is a 30, 60, 90 right triangle. Okay, so how do I find this whole length here? Okay, well if this side is A, right? This is my S, this is my S, this is my S root 2. This is an isosceles triangle, right? So if this is A, then DB also has to be A, right? These two sides are congruent. And then for my 30, 60, 90 right triangle, the side across from the 30 is my short side. So this is my S. So A is my S. And then how do I go from S to the long side across from the 60-degree angle? Okay, whatever my short side is, I multiply that times the square root of 3. So this side is going to be the short side, which is A, right? This is A times the square root of 3, right? Okay, so they're asking for the length of AB in terms of A. We don't have any numbers, so we're just going to use this generic variable A. So the length of AB is simply going to be that guy, A square root of 3 plus this guy, right? I'm just adding the two lengths together. I'm going to add AD plus DB, and I get this expression. So this is the length of AB in terms of A. Okay, 40, I found this problem. I love these types of problems. So you really have to understand your special right triangles to do a problem like this. We got 30, 60, 90 triangles. We got 3 of them slapped together. Okay, so this is 30, this is 60, this is 30, this is 60. So all these are the same. All these are 30, 60, 90. And I'm trying to go from the hypotenuse of this right triangle to the long leg of this right triangle. Okay, now how do I, these are all my sides, right? Side, side, side. Okay, so all these are the short sides. All of these, this is going to be the long side of this triangle. This is going to be the long side of the middle triangle, and this will be the long side of the third triangle. Okay, now this is the hypotenuse. 16 is across from the 90. This is the hypotenuse. This is my 2S, right? So how do I go from 2S to S? I'm going from large to small. I'm going from big to little. So I have to divide by 2. So if I take 16 and divide by 2, that gives me 8. Okay? So now I need to find this side so I can find this side. Okay, so the pattern is I'm going to go from this side to this side, to this side to this side, to this side to this side, and that will eventually get me to X. All right, so what is this side for the top triangle? This is my long side, right? S, 2S, this is my S root 3, right? S root 3. So I simply take the 8 and I slap on a root 3. So this side is going to be 8 times the square root of 3. Okay. Now that I have this long side here, okay, now if I look at the middle triangle, now the long side of the first triangle now becomes the hypotenuse of the second triangle. Okay, so the hypotenuse of this middle triangle is 8 root 3. How do I go from 2S to S? It's the same pattern. I'm just going to divide by 2. Okay, so to go from 8 root 3 to the short side, I divide 8 root 3 by 2, and I get 4 root 3. Okay, how do I go from short side to the long side of the middle triangle? I slap on a root 3. 4 root 3 times another root 3. Root 3 times root 3 is 3, so 4 times 3, that's 12. So now this long side of the middle triangle is 12. That becomes the hypotenuse of the last triangle. How do I go from the hypotenuse to the short side? 2s to s, I divide by 2. So 12 divided by 2 is 6. That's my short side. How do I go from short side to long side? I slap on a root 3. So x is equal to 6 root 3. Got to follow the pattern. So we divide by 2, slap on a root 3. Divide by 2, slap on a root 3. Divide by 2, slap on a root 3. Okay? Love those types of problems. So my final answer is 6 root 3. Rewind that if you need to. All right, 41, find the lengths of the sides of the triangle. Okay, this is 45. That's a right angle, so that means this is 45. This is our classic isosceles right triangle. All right, so I'm going from hypotenuse to leg, right? Am I going from big to little, or am I going from little to big? I'm going from big to little, right? The hypotenuse is the longer side, so I have to divide. So I have to divide by, and remember, this is s root 2, right? Because I only have 2 angles, 45 and 90. That's my root 2. 30, 60, 90, I have 3 angles. That's my root 3, or 3 different angles, we should say. Okay, so I have to divide by the square root of 2 since I'm going from big to little. Now, when I divide by the square root of 2, I can't leave the radical in the denominator, so I have to rationalize that. So I'm going to multiply by root 2 over root 2, which is a big fat 1. So now on top, I have 16 times the square root of 2. On the bottom, I have root 2 times root 2, which is 2. And then 16 divided by 2 is 8. So this simplifies to 8 times the square root of 2. Okay. All right, here we go. Last page. Last page. Let's finish up here. Okay, solve for x and y. Okay, so I can't use Pythagorean theorem because I have 2 unknown sides. Okay, I need at least 2 sides in a right triangle for Pythagorean theorem. So this tells me I probably need to use trigonometry. Now remember, Pythagorean theorem, special right triangles, trigonometry, all of those only work for a right triangle. Okay, law of sines and cosines are for our non-right triangles. So this tells me I'm probably going to need to use trigonometry. Okay, Sohcahtoa, right? So the way I taught you guys to do this is step 1, circle the angle. Let's solve for x first. Step 1, circle the angle. Step 2 is label. 2 is my opposite. X is my adjacent. Okay, we don't have any information on the hypotenuse. So which one has opposite and adjacent? Tangent. Now I'm finding a side, so I don't use inverse. I just use regular tangent. So I say tangent of my angle is equal to opposite over adjacent. Okay, notice x is in the denominator. So when x is in the bottom, you divide by your trig function. So x is going to end up being 2 divided by tan of 5 degrees. And if you plug that into your trusty calculator, grab my answer key here. Now here, I went back and changed this. I wanted you guys to round this to the nearest hundredth. I went back and changed the original file. But the reason why I asked you guys to round to the nearest hundredth is because for x, you're going to get 22.86. Okay, if I round that to 2 decimal places. Now let's go find y. Okay, so now let's circle our angle. Label, the 2 is still the opposite, but now the y is the hypotenuse. So which one has opposite and hypotenuse? That's sine. So I'm going to say sine of 5 degrees is equal to opposite over hypotenuse, 2 over y. The variable is still in the bottom, so I'm going to divide by my trig function. So y is going to be 2 divided by the sine of 5 degrees. And when you type that into your calculator, you actually get 22.95. 22.95. Now, if I just asked you to round to the nearest whole number, both of them would be 23. If I asked you to round to the nearest tenth, then you would have 23.0 and 22.9. So I really wanted you guys to notice that these two answers, these two lengths are almost the same. So why is that? How is that possible that the hypotenuse, which is the longest side, is almost identical? It's only a few hundredths off. The reason why that is because we have such a small angle. 5 degrees, guys, is nothing. I mean, that is like no angle at all. That's like the skinniest angle ever. Okay, so it does make sense that this base is going to be darn near close to the length of the hypotenuse because my angle is so small. Okay, All right, 43. Some of you guys were confused by this little guy. This guy is called theta. It is a Greek alphabet. It's a Greek letter of the alphabet, I should say, just like pi, sigma, that kind of stuff. It's just a variable. You could treat it like an x. We're finding the measure of the angle. Okay, so step 1, circle the angle. Step 2, label. That's my opposite. 5, that's my adjacent. It's still trigonometry. Now, which one has opposite and adjacent? Tangent, but notice I'm finding an angle, so I must use inverse. Inverse tangent of opposite over adjacent. Plug that into your calculator, and you're going to get approximately, this doesn't tell you how to round, so we'll say approximately 58 degrees. If you round that to the nearest whole number. Okay, 44, a person is standing inside the top of a lighthouse and spots a boat in the water at an angle of depression of 28 degrees. The lighthouse is 45 feet tall. What is the line of sight distance from the lighthouse to the boat? Okay, so this is my best. I'm not much of an artist here, so let's see what I can do. Shade that, shade that, shade that. That's not so bad. We got a person standing up there, like a tower or something. And we got, the water down here, and we have a boat. We have a canoe or something, a boat out in the water with Mr. Manice standing out here making a fool of himself. And it says that the person standing on top of the lighthouse spots a boat at an angle of depression. Now remember, we have this imaginary horizontal line that we're just assuming is parallel with the water or the ground. And we have this angle of depression to the boat of 28 degrees. Now notice the angle of depression is never inside the triangle. Okay, it's always outside. But we're assuming these are right angles with all these word problems. So we need an angle inside the triangle. Well, if that's 28, here's the z, right? The z for alternate interior angles. So if that's 28, then this guy's 28 degrees. Okay, so now I got an angle inside the triangle. And the height of the tower, the lighthouse, is 45 feet. It says, what is the line of sight distance? When you say line of sight, that literally means you're looking down that line. So this person is looking down this line. That's not the same as the ground distance, okay? So we are trying to find this line of sight. Literally, we're looking at each other, okay? All right, so we're going to use trigonometry. Step 1, circle your angle. Step 2, label. That's opposite. X is your hypotenuse, so we need sine. So I'm going to say sine of my angle. I need regular trigonometry because I'm finding a side length is equal to opposite over hypotenuse. The variable is in the bottom again, so we're going to divide. 45 divided by the sine of 28 degrees, and we get 95.9. It doesn't tell us how to round, approximately 96 feet. Make sure you guys are paying attention to what it asks you to round to. Now the exam is multiple choice, so you won't have to make that determination, but you always want to make sure you read the directions. Okay, does that make sense? 96 feet? Yeah, I buy that. Now remember, if this were a 30-degree angle, right? We talked about this in class. Here's the deep understanding. If that were a 30-degree angle, then this would be half of that, right? So if that were 30 and that's 45, I'll just double it, and this will be 90. Well, it's not 90. Why is it not 90? Well, because my angle's not 30. Okay, so we're a little off. So, but yeah, we're close. So I say, yep, that sounds about right. Makes sense to me. 45, here we go. 3 more problems. Find the length of BC. Okay, so I can't use trigonometry because we don't have a right angle, or we don't know that it's a right angle. Okay, we can't make an assumption here on this particular problem. So what do we have? I have angle, and a side. I have AS. Okay, so that tells me, I'm probably going to have to use law of sines or law of cosines. And here's where you're going to have to remember, which one is it for AAS? That is the law of sines. Okay, so make sure you have which triangles you're going to use law of sines and cosines for. Cosine is only for SSS and SAS. Everything else is law of sines. So this is going to be pretty easy. Now, I need the length of BC. Okay, so I'll put the X here. Now, in order to know this length, I need to know the angle across from it. I don't have that, so I got to find it. So I'm simply going to add 45 and 70 and subtract from 180, since 3 angles of a triangle add up to 180. So 180 minus 70 minus 45 gives me 65. So this guy's 65 degrees. Now the law of sine says the sine of the angle divided by its opposite side is equal to the sine of another angle divided by its opposite side. Okay, so I can set up a proportion to say sine of this angle divided by its opposite side length is equal to, now here I need to pick the 70 because I have a 15 here. The 45, I don't have any information over here, so the 45 doesn't help me. So I'll do sine of 70 divided by its opposite side, 15. Okay, I got my proportion. I can cross multiply. X times the sine of 70 equals 15 times the sine of 65. I need to get x by itself, so let's divide both sides by the sine of 70. Okay, those will cancel. And I get x is equal to, now here, once again, guys, I told you guys in class, there's a lot of stuff going on here. I would probably do this in 2 different steps. So I would do sine of 15 times the sine of 65. Go ahead and get a number, and then press divided by the sine of 70 and get a number. Okay, so I did go back and change this one to round to the nearest tenth, so we're going to get 14.5. And we don't have any units, so that's the best we can do. 14.5. All right, find the measure of all 3 angles. Okay, I don't have a right triangle, so I can't use trigonometry. I have side, side, side. S, S, S. That's going to be the law of cosines. This is the one that's a little bit trickier. Okay, and our formula is a squared, okay, whatever angle that we're talking about here. This says find the measure of all 3 angles. Okay, so which one do you want to start with? Doesn't really matter. I'll start with angle A. So the law of cosines says that the side across from the angle in question squared is equal to the sum of the other 2 sides squared, b squared plus c squared, minus 2 times the product of these 2 sides times the cosine of the angle in question. Okay, so that's my formula. So let's go ahead and plug this in. So I have this, the 11.6 squared is equal to, and it doesn't matter which one of these comes first, I'll do 7.4 squared plus the 15.2 squared minus 2 times 7.4 times the 15.2 times the cosine of the angle that I'm trying to find. Okay, now I can't plug all this into my calculator because I'm trying to find an angle. When you're trying to find the side with the law of cosines, you can just plug all that stuff straight in. But here I've got to do some simplification. So if I simplify this, 11.6 squared, that becomes 134.56. I'm not going to round early because when you round early, guys, your final answer is going to be off a little bit. So you always want to keep a few decimal places until the very end so you can be as accurate and precise as possible. The 7.4 squared plus the 15.2 squared, that comes out to be 285.8 minus 2 times 7.4 times 15.2 gives us minus 212 cosine of angle A. Okay, now I got to get cosine of angle A by itself, so I need to move this guy over. So subtract negative 285.8 from both sides. Those will cancel. And I'm going to be left with, over here, I'm going to be left with negative 151.24 equals the negative 212 cosine of A. All right, I'm trying to find an angle. Okay, so I need to divide both sides by negative 212, but I'm finding an angle, so I need to do the inverse. So I need to do the inverse cosine of this, negative 151.24 divided by the negative 212. And if you type that into your calculator, that comes out to be approximately 44.5 degrees. Okay, so that's angle A. So now I need to do the same thing. So I will do it now for angle B. But now I'm looking at this guy is the one that comes first. Square that equals the sum of these 2 guys squared. Okay, so for angle B, that's for angle A. For angle B, I'm going to start with this side. So we got 15.2 squared equals the sum of these 2 guys squared. Doesn't matter which comes first. Minus 2 times the product of those same 2 sides that are sandwiching the angle. Cosine of B. Okay, so if I simplify all this, this comes out to be 231.04 equals 189.32 minus 171.68 cosine of b. I need to get cosine of b by itself, so I need to move this guy to the other side. So subtract the 189.32. And those guys will cancel. And I'm going to be left with 41.72 equals negative 171.68 cosine of b. I need to divide both sides by the negative 171.68, and those will cancel, so I need to take the inverse of this thing. So inverse cosine of 41.72 over negative 171.6, and that comes out to be an obtuse angle, as it appears to match the diagram. So now you might say, oh man, I got to do it one more time for C. Do you? This is 44.5, this is 104.1. I have two angles in my triangle, right? So for angle C, all I have to do is subtract these two guys from 180. So 180 minus the 104.1 minus the 44.5, and that gives me 31.4 degrees. Now, how could I check? I could take all three of these guys and do what, right? Add them up. Make sure they add up to 180 degrees. For sake of time, I'm not going to do that on the video. All right, we're almost there, guys. Last one. Last one. I picked this problem too. I love it. I love these combination type problems because you have to know what you're doing. Definitely have to know what you're doing to figure these out. It's saying, what is the measure of the angle between highway A and highway Q? So there's A, there's Q. I know it's hard to see that. Hopefully y'all can see it on your paper. So basically, I'll put an X here. I'm trying to find, or actually, on my answer key, I put a Y there. So we'll call that Y. I'm trying to find the measure of angle Y. Okay, so over here on this first triangle, I have a side, an angle, and a side. So I have SAS. Okay, so that tells me I'm going to use the law of cosines because we don't have any right angles in these triangles. So all the other stuff in this unit, throw out the window. Okay, so I've got SAS. That will allow me to find this opposite side, which I will call X, or this little pentagon with a D in it. Okay, once I have the X, then I'll have side, and then I'll have a side and an angle. I have SSA, side, side, angle. That's the bad word, but remember the bad word does work for the law of sines. So I'm actually going to end up having to use both of these guys on this problem. The law of sines for that guy and the law of cosines for that guy. So I love this problem. All right, so let's take it one step at a time. All right, so my angle is 24, so the side across from that is the one that comes first. So we'll square that guy. So that's like my a squared equals b squared plus the c squared minus 2 times b times c times the cosine. Now here I have my angle, 24 degrees. Now here I don't need to break this down because when I'm finding a side, that's supposed to be a squared. I can literally just type all this straight into my calculator. Type in 150 squared plus 220 squared exactly the way you see it. If you do that, you'll get x squared is equal to 10,606. I'm going to take the square root of that, and x is going to be equal to about 103. Okay, so this side length right here is 103. Okay, right at it. Okay, so now I have this side, I have this side, and I have this angle. So now I can use the law of sines. I can say the sine of 56 over its opposite side, the sine of 56 over its opposite side, which we know is 100, is equal to the sine of the angle that I'm trying to find, the sine of y, over its opposite side, which is what we just calculated. That's the 103 number. Okay, I can cross multiply, so I'll get 100 sine of y equals 103 times the sine of 56. I need to get the sine of y by itself, so let's divide by 100. Those will cancel. And now I'm trying to find an angle, right? So I got to use the inverse. So it's going to be the inverse sine of all of that stuff. 103 times the sine of 56 over 100. Now how would I enter that in my calculator? Again, I would break this down into a couple of steps here. I would do 103 times the sine of 56, get a number, divide that by 100, get a number, and then I want the inverse sine of that. So I go second inverse second answer, and that gives me 58.6 degrees. So angle Y is 58.6 degrees. Whew, you made it, guys. You made it. Hope you guys enjoyed that. Part 2 of the midterm review video. I wish you guys the best of luck. Study hard, and we will see you on the next one.